Welcome back from the ad break, and let's continue with our lesson. So we were busy with scientific notation. Now let's look at scientific notation when the numbers are greater than 1. So when the number that is being written in scientific notation is bigger than 1, then the exponent to the power with the base 10 will be a positive integer. Let's look at the following examples. So write the following numbers in scientific notation. Do you remember those 3 points to make sure that we successfully write our number in scientific notation? Well, firstly, we need to make sure that the decimal that we are working with is between 1 and 10. So in this first number that we have been given here, 324 million. So we need to make sure that the decimal is between 1 and 10. So in this case, the decimal is going to be 3,24. Because it has to be smaller than 10 but bigger than 1. And we know that we are going to multiply this with a power of 10. Now we need to figure out what the exponent to that power of 10 will be. Now remember, we are going to now look at those place values. This is where we have placed our comma there. So we are going to look how many times this number was multiplied by 10, or sorry, how many tens were multiplied to this number for us to get that 324 million. So we know that when we multiply by 10, it will be 1, 2, 3, 4, 5, 6, 7, and 8. So we know that if we multiply this number by 8 of these tens, then definitely we will get to our number of 324 million. So that means that the answer here is going to be 3,24 multiplied by 10 exponent 8. Now moving on to the next one, again, we know that it must be a decimal that is between 1 and 10. So that is going to be 2,3, and this is going to be multiplied by a power of 10. Again, if the comma is placed here at 2,3, how many tens are we going to multiply with so that we get to 23,000? So from 2,3, how many tens do we multiply to get to 23,000? So there's going to be 1, 2, 3, and 4. So that is going to be 2,3 multiplied by 10 exponent 4. So we look at those place values. Then we have 40. And what is 40 now written in scientific notation? That is just going to be a 4. And that is going to, because remember, it needs to be a decimal that is between 1 and 10. We can even say 4,0, but that is going to be multiplied by a power of 10. Now, if that comma is right there, how many times would we multiply 10 by 4 to get to 40? So that is just going to be one place value, and that is going to be 4,0 multiplied by 10 exponent 1. Do you feel you know how to write numbers in scientific notation? Let's look at more examples. So again, we are going to be writing numbers in scientific notation. The first number that we've been given there is 876 million. What is the decimal that you think we are going to write there between 1 and 10? Are you thinking of 8,76? Because you would be absolutely correct. Remember, we are going to multiply this by a power of 10, and we need to count how many tens we are going to multiply into 8,76 so that we can get to our number of 876,000. So that is going to be, 876 million. So that is going to be 1, 2, 3, 4, 5, 6, 7, and 8. So that is going to be exponent 8 and exponent 8. So our answer there, 8,76 multiplied by 10 exponent 8. Let's go over to our next one. So there we have been given 89,100,000,000. So we are going to write that in scientific notation. Now, do you know what decimal we are going to use to start off our scientific notation? Well, if you are thinking of 8,91, then you are absolutely correct. And we already know that that 8,91 is going to be multiplied by a power of 10. So what is going to be the exponent to that power of 10? So we can see that our 8,9, our comma is going to be over there. So how many tens are we going to multiply to 8,91 so that we can reach our given answer of 89,100,000,000. So from here we are going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can see there that this 8,91 must be multiplied by 10 to the exponent 10 so that it can reach that 89,100,000,000. Let's look at our next one. We are going to write it in scientific notation. So we have 100. And what do you think the decimal is going to be there for 100? Yes, it is going to be 1,0. Remember, our decimal needs to be between 1 and 10. So we need to make sure of that. And of course, we know that this is going to be multiplied by a power of 10. So if our comma is over there, how many times are we going to multiply by 10 to get to 100? That is going to be 1, 2. So that is going to be multiplied by 10 squared. Of course, 1 multiplied by 10 squared is 100. Then let us expand and simplify the following scientific notation. So we have here 1,234 multiplied by 10 to the exponent 6. Now we have been given the scientific notation and we must now expand that scientific notation. So remember, if we have 1,234 and we are multiplying that by 6 tens, so that is going to be multiplied by 10, 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 and lastly multiplied by 10. So what is that answer going to look like there? So if we have there our 1,234, well, we are going to multiply it by 10 6 times. So that means 1, 2, 3. And then we are going to have again 4, 5, and 6. And in those place values where there is nothing, we are just going to place our zeros to show that we have multiplied by 10 6 times. So that is going to give us an answer of 1,234,000. And just to double check our answer, if our comma was there, we would be saying we are multiplying by 10 to the exponent 1, 2, 3, 4, 5, and 6, like we have been doing. So that is absolutely correct. Let's see if we can expand more of these. Now we have the 4,5 multiplied by a 10 exponent 1. So that just means we have 4,5 and we are multiplying it by 10. So 4,5 multiplied by 10, that is a simple 45. This next one is 2,01 multiplied by 10 to the exponent 0. And because we know our exponent laws, we know that 10 to the exponent 0 is equals to 1. So this is 2,01 multiplied by 1. And according to our properties of 1, we know that that is going to be 2,01. Let's now finish off with the last concept in our concept map, and that is problem solving. So we are just going to calculate these few expressions without the use of a calculator. So now we are going to use our exponent laws to calculate these expressions. Now we have 5 multiplied by 10 exponent 4 multiplied by 2 exponent 3. Now 5 we are just going to leave as it is, but 10 can be written as 2 multiplied by 5, and this product is going to be raised to an exponent 4. And then we have multiplied by 2 exponent 3. Now, according to our exponent laws, we know that if a product is raised to an exponent, then we know that each factor in the product will get that exponent that is raised there, or each exponent within the product is going to multiply with the exponent there. So that is going to be 2 exponent 4 multiplied by 5 exponent 4. And that is going to be multiplied by 2 exponent 3. Now, do we remember our exponent laws? They say that if we are multiplying the same base, powers of the same base, we can add those exponents. So looking at our 5 there, we know that there is an exponent 1, and we are adding that with the exponent 4. Why the exponent 4? Because they have the same base. And then we are going to multiply this with a 2, and that is going to be the exponent 4 multiplied, not multiplied, we are multiplying powers of the same base, so we are going to add those exponents. So that is going to be a 4 plus 2. What is our final answer going to be? That is 5 exponent 4 multiplied by 2 exponent 6. And then this last one here, we are just going to say there, so we have a negative 7 multiplied by 10 squared multiplied by negative 8 multiplied by a 10 cubed. So we could say that we have 2 scientific notations here that are being multiplied. Now, because we know our exponent laws, we can just say there that we are going to combine the ones that have the same base. So we can say negative 7 multiplied by negative 8, then we are going to multiply that by 10, and the exponent there is going to be 2 plus 3. Why are we adding these exponents? Because we can see that these these powers have the same base, and that is why we are going to add them there. Now, remember, a negative number with a negative number, if we are multiplying it, will produce a positive number. So we are going to have a positive, and what is 7 multiplied by 8? Yes, if you are thinking of 56, then you are correct. So a negative 7 multiplied by a negative 8 is equals to that positive 56, and this is multiplied by 10 to the exponent of 5. 10 to the exponent of 5. Now, of course, we can go and expand this calculation. So that is going to be now that 56 multiplied by 5 of these 10s. So that is going to be now our 56. And when we multiply it by 5 10s, then that is going to give us, let's just multiply it there by 5 10s. That is going to be 1, 2, 3, 4, and 5. So our final answer is going to be 5,600,000. So that is the end of our wonderful lesson. We are so glad you joined us, and I hope you enjoyed the lesson just as much as I did. Thank you for joining us. We hope to see you next time. Goodbye.